Okay, let's do something fun. Let's do forces, vectors, gravity, mash it all together. So we have three objects here, objects A, B, and C, and we want to calculate two things. Number one, the force that objects B and C pull on A, and number two, the gravitational force that C pulls B with. So if we're looking at the way we've set this up, we have these three objects, and object B is going to be pulling A up a little bit, right? Because when two objects are exerting gravitational force, they want to pull each other in, and C is going to be pulling over here. That's the wrong way, over here. So if we were to kind of draw this vector diagram out, so this would be the force of B on A over here, and then C is pulling it here. Again, these are not to scale, they're just kind of what we have going. F of A on, I guess, F on C on A. And so the net force is going to be somewhere in this direction with some theta, all right? So that's cool. So we have to basically solve these. So we want to solve FB on A first. Well, we know generally that FG is equal to negative. Well, we don't really need to care about the sign because we're going to be taking into account which way it's going. So F of B on A is just gravitational constant, MB, MA over R AB squared. And plug all of this in. 6.67 times 10 to the negative 11. Put the units in there. I'm too lazy. The mass, we have 1 times 10 to the 18 kilograms. And we have 2 times 10 to the 18 kilograms here. And that's all divided by 2.5 times 10 to the 9 meters squared. And if we put this into our calculator, let's see what we get. 6.67 times 10 to the negative 11 times 1 times 10 to the 18 times 2 times 10 to the 18 divided by 2.5 times 10 to the 9 squared. And we get 2.13 times 10 to the 7 newtons. And that is going up. So does that make sense? Yeah, well, this will be 36 minus 27, that's 27, minus 18. Yeah. You always want to make sure your answers make sense. So this is FB on A in full vector form because we have the up there. So if we want to calculate now FC to A, then we basically do the same thing, but we just swap out a few values. So this is going to be GMCMA over RAC. And let's start a new page because it's going to get a bit messy. So FAC is equal to 6.67 times 10 to the negative 11. Then we had 1 to the 18 and 4 to the 18. 1 times 10 to the 18 kilograms and 4 times 10 to the 18 kilograms. Divide all of that by RAC, which was 5 times 10 to the 9. 5 times 10 to the 9 meters squared. And we get here 6.67 times 10 to the 11 times 1 times 10 to the 18 times 1 times 4 times 10 to the 18. Divide all of that by 5 times 10 to the 9 squared. 1.07 times 10 to the 7 newtons. And that is going to the right. Yes, being pulled right. Okay. Yeah, I mean, that makes sense because this is basically twice the distance, even though it's much heavier, twice as heavy. Well, we know that the square is going to dominate, so it's obviously going to be weaker. So we have FAB, we have FAC. So now we have to find the net force. So if we go back to our vector diagram we drew before, so this is 1.07 times 10 to the 7 newtons, and this was 2.13. 2.13 times 10 to the 7 newtons. So this, we'll call it F net A, is equal to, well, we can just use Pythagoras. So we've got 1.07 times 10 to the 7 newtons squared plus 2.13 times 10 to the 7 newtons squared. Take the square root. These are just absolute value signs. It's not like I'm adding an extra ones or anything. A really bad square root sign. Oh my God. 0.7 times 10 to the 7 squared plus 2.13 times 10 to the 7 squared. Take the square root. We get 2.4, 2.38 times 10 to the 7 newtons. So that's the net force that is being exerted on A. And of course, got to find the angle because it's not a vector without a direction. So theta, well, we know tan theta is opposite over adjacent. So it's going to be equal to tan -1 of 1.07 times 10 to the 7 over 2.13 times 10 to the 7. And let's see what we get. 1.07 should be really small. Yeah. 26. Okay, I'll take it. 26.6 degrees. This is not that small. I mean, I changed these numbers around before, so I'm not 100% sure we're going to get. But we can say our final answer, the net force on A is equal to 2.38 times 10 to the 7 newtons. And then we're going to go, this is up 26 degrees to the right. So up 26.6 degrees right. And that is our answer. So this thing in space, it's feeling 23 million newtons of force and at some angle 26.6. So that's the first part. We still have to calculate the gravitational force of object C on B. So object C on B, so B is going to be pulled this way from C, but we don't know this distance, right? So let's get ready for question number 2. We want FC on B. That is going to be equal to G MC MB over RCB squared. Okay, RCB, we don't know, but we can calculate it because we know RAB. We know these other two, and we can just use Pythagoras, which will be very nice. So we do know that RCB is equal to RAB squared plus RAC squared, and then we take the square root. So here we go. It is 2.5 and 5 plus 5.0 times 10 to the 9 meters. These are all squared. And I'm just going to put that to 1/2. So RCB is equal to 5.0 times 10 to the 9 squared. Big surprise. Okay, 5.6 times 10 to the 9 meters. Lovely. So we can do that. However, again, if we think back to our triangle, we are going to need this angle. Actually, we're going to need, well, I mean, it's going this way, so I guess we could use that angle there. If we have A, B, and C. So we need this angle. It's a really bad right triangle. So tan theta there, RAC, RAB. So if we have theta here, then tan theta is equal to RAC over RAB, which would mean that theta is equal to tan -1 of RAC 5.0 times 10 to the 9 divided by 2.5 times 10 to the 9, which is -1 of 5 times 10 to the 9 divided by 2.5 times 10 to the 9. 63 degrees. And again, that's where, no, did that wrong. We are calculating it from down here. My bad. So we got to flip these. These things happen. RAC. So we just flip these and we'll end up with 27. Wasn't feeling right. Was not feeling right at all. Okay, 2.5 times 10 to the 9, 5.0 times 10 to the 9. And yeah, we got 27 degrees. All right, lovely. So we got 27 degrees there. So now we just need to calculate FCB, which we can do. And the mass of C is 4 to the 18. And the mass of B is 2. Okay, lovely. Divide all that to the 9 meters. And we get RC. No. RCB, that should be F. We get FCB equals, let's do it. Okay, 1.7 times 10 to the 7 newtons. So our full answer is going to be 1.7 times 10 to the 7 newtons. 1.7 times 10 to the 7 newtons. Okay, then this will be southeast. Yeah, south 27, well, not south. Let's call it down 27 degrees right. And that is our answer. Let me make that F a little nicer. And there we go. What a fun problem. Good stuff.